And Andrew Nelson, who was on our last space panel, will be moderating this one. So over to you, Andrew.
Thank you very much. Thank you very much. Well, I'm very excited today to be moderating this panel of distinguished gentlemen. We're supposed to be focusing today on overcoming the challenges of introducing new, cost-effective technology into space programs. We were giving some elaborating comments from the conference organizers, which I won't read, but generally focused on what's really the technologies of the future which are going to be driving the expansion of the space markets, and in particular, what specific technologies in these space programs would we look to drive the costs to much more affordable levels. And in particular, there was a question about reusability of launch vehicles, parts of launch vehicles that they wanted us to address, as well as new and exciting satellite technologies that are going to be in different design philosophies that are out there as these costs fall. So the panel today we have with us is Jean-Marc Astorg from CNES, and we have I keep saying Dr. Fu, but it's Mr. Fu from Great Wall of China, launch our panel sponsor. Sir Martin Sweeting, who's the founder and chairman of Surrey Satellite, and Ben Droste, Lieutenant General, retired, former Chief of Staff of the Air Staff of the Netherlands Air Force, one of the founders of Space Expedition, which is now part of X-Corps Aerospace, and a good friend. So I'm excited to be with the group. Well, let's just launch right into it. We've all seen the videos, probably, of SpaceX and Blue Origin landing or attempting to land first stages on barges and on land. We've seen some successes from suborbital space with Blue Origin. We've seen one success on land from SpaceX on a launch out of Kennedy Space Center. And they say that this is going to drive costs significantly lower because of the reusability of those launchers, of the first stage, which is a significant cost. But there's been challenges from industry that, okay, you might be able to get it back, but can you truly reuse it? What's the cost of reprocessing the stage? Is it really a savings or not? There are several new launcher programs out there, and I think one of them is represented by Jean-Marc, and that's the Ariane 6 program. So the ESA member states have decided the Ariane 6 program during the Luxembourg conference in December 2014. Can you tell us what the progress is of Ariane 6 today? And tell us about the cost targets of Ariane 6 versus Ariane 5, and how are you going to get there? And then we'll get the gotcha question a little bit later.
Thank you, Andrew. Good afternoon, ladies and gentlemen. First of all, I would like to say that I'm very glad to be here in Abu Dhabi. This is my first time here, first time in the summit, and I'm very much impressed about the organization, about the city, and also about the space program you have here. So it's really impressive, and especially your mission to Mars. Okay, to answer to your question, I think I should first recall why 10 European governments have decided to fund a brand new launcher called Ariane 6. The target is to divide the cost by 2 with regard to Ariane 5. The reasons behind that are obvious. The pressure on cost on the commercial market is more and more important, especially due to new competitors coming from California or the American states. And it was obvious to everybody that with Ariane 5, which is a launcher that has been designed in the 90s, with an organization which is frozen because of the organization from the 90s, we could not decrease the cost significantly. So this is why the government have decided to fund a new launcher. And you know, our business model for launchers in Europe is based on the fact that governments pay for the development of launchers in order to have an independent access to space. But also, we need to put it on the commercial market because the number of launches per year on the institutional market is not enough to maintain reliability. So we have to compete on the commercial market, and I have to say that Aerospace is quite successful on this kind of market today. So Ariane 6 has been decided in December 2014. We are today in the phase of designing the whole launcher and the ground segment. The target really is to divide the cost by 2, and we are doing that by 3 factors. First one, synergies between the different European launchers. Today, we operate in Europe, Ariane 5, Soyuz, Vega. 3 launchers, that's good to serve the whole market, almost the whole market. We are missing micro launchers, but we do not have a single engine common to these launchers. So obviously, this is not the optimum. So with Ariane 6 and Vega C, at least we will have one common engine, which is the solid propellant motor that will be used as a first stage of Vega and also as a strap-on booster of Ariane 6. Wow. That will allow us to produce that engine 35 units per year. So first one is synergy and launch rate. Second one is organization of manufacturing. You know, I've been lucky to see and to live the start of Ariane 5 development and the start of Ariane 6 development. I can tell you it's completely different. Industry is in charge of organizing now on Ariane 6 the manufacturing of the launcher, and they do it smartly. They have the target to optimize the production from the very beginning. When we did it in CNES a few years ago, first we looked to the design, and manufacturing came after. So as a matter of fact, it's not completely optimized for manufacturing today on Ariane 5. So industry is doing the reverse. They are organizing some clusters of manufacturing, metallic structures in Germany, composite structure in Spain, and so on and so on. And that will be the way to decrease the cost. And the third factor of reducing the cost on Ariane 6 is innovation. And in Ariane 6, we put today the result of research and technology that was conducted 10 years ago, and now we introduce it in an operational launcher. I can take as an example the composite structure of the solid rocket boosters. These boosters will be the largest in the world with monolithic propulsion module with a composite structure. And that leads to a big cost reduction with regard to the heavy metallic structure we have today on Ariane 5 boosters. We will have also a sandwich nozzle on the Vulcan engine. We will have a laser ignition system on Vinci. We will largely use friction stir welding to produce the tanks. So many examples of what we put on Ariane 6 to decrease the cost by a factor of 2. And we have no reusability, but I guess we will come back on that later.
Yeah, we'll come back to that. So I'm going to do a quick follow-up. So in terms of manufacturing, for example, I've had the good fortune of, at one point in time, visiting both some of the CNES related suppliers over the years when I lived in France and worked in the aerospace industry. And I've also toured the SpaceX new facility in Hawthorne. And I know SpaceX is trying to drive automated technologies, such as some of the automotive robotic welding for some of their pieces and that sort of thing. And of course, it's almost a vertically integrated system. They say that's a much more efficient system in the aerospace sector, whereas Ariane 6 and Ariane 5, by the very nature of the multinational coalition with suppliers all over Europe, is there going to be enough efficiencies that you can capture in what Elon Musk might say is an inherently inefficient system?
Well, maybe we are inefficient, but we have more than 50% of the market today.
This is true.
Also, it's true that you cannot compare the factory of today, SpaceX, for instance, with factory of Ariane 5, which have been designed and organized, as I said, in the 90s. Right. So with Ariane 6, we are doing it completely differently. Yeah. And that's what I tried to explain before, that our factories will be completely different for Ariane 6 than they are for Ariane 5. But they will be spread in Europe because we have, and I think it's a very good heritage. In Europe, we have the manufacturing of the different parts of the launcher everywhere in the countries that contribute to fund the development of the launcher.
Yes.
And that's good because we have a strong industrial government basis to develop and operate the launcher later on.
Absolutely. And certainly that model is used very effectively in the aviation sector with the manufacturing of all of the Airbuses and that sort of thing from different pieces and parts from the country. And so if anyone can do it, I'm sure you guys can. You've done it before. Well, Mr. Fu, welcome
Thank you.
to the conference. I'm very excited that China Great Wall Corporation could be here. You have a very great history in of launchers, and you're about ready to open up a new Space Launch Center,
Yes.
Which is a very exciting development. Can you update us about what's new going on in China with your launcher programs? And again, if you can, put a spin on it about reduction of costs from historic norms and increase of reliability.
Okay. Thank you very much for the introduction. Actually, it is a great pleasure to be here in Abu Dhabi to talk about the cost-effective solution for the space program. Actually, in China, we have a long history for developing our space systems, including launcher and satellites. Since 1970 up to now, we have conducted over 200 launches with the Long March fleet. So we keep updating our fleet, actually. Since last year, we have successfully launched two new type of launcher. These two launchers, namely Long March 11 and Long March 6. Long March 11, actually, it is a small launcher, but it's solid. It is a solid propellant launcher that is targeting for the small and micro satellite, even nano satellite launch. And also Long March 6 is a liquid propellant launcher. It is using the lux and the kerosene as the propellants. This is the first time for China to develop a launcher using that kind of propulsion technology. And this year is also the big year for China's space industry. We are going to conduct two maiden flights for two large launchers. One is Long March 5, which is going to have a 14-ton to GTO capability. I guess it will be the largest one currently in the market. And also another one is the Long March 7. So Long March 7 will be used for the future China's space station. And Andrew also mentioned about that we are going to have our new launch site in South China, Hainan Island. That launch center will be in operational with the launch of either Long March 5 or Long March 7. So these kind of new launch programs will have China for our own space programs. You know, currently our Long March 3B is the workhorse for the current Long March fleet. It has a capability of 5.5 tons to GTO, so we can compete with the current players in the market. And also we know the challenge in the market, so people, our competitors are lowering their cost, lowering their price. So we also identify some of the cost factors in our process. So one of the things we're going to do is to reorganize some of the process. So from the manufacturing and also from the design perspective, we would like to make it simple, not so complicated. And also like our colleagues here, we may reuse some of the products and equipment on different types of the launchers. So this is one thing we are going to do. The other thing is we found from previous experiences that our launch operation cost is a little bit high compared to our competitors. So right now you see we launch from some of the land-based launch sites, like for the GTO launches, we launch from Xichang, the satellite launch center, which is in southwest China. But we use the tracking ships for the TT&C. So that is quite costly. So in the future, we are going to find some ground stations for this kind of TT&C operation. And also we're going to use, actually we already started to use China's data relay satellite for this kind of TT&C work. That would also help us to keep our costs down, and then we can be more competitive in the market. And also, we have eyeing some other new opportunities emerging in the market. That is the launch requirement for the small and nano satellites. Nowadays, even universities can build CubeSat, but the most difficult challenge for them is not to build a satellite, but to get access to space. In China nowadays, we have about 20 launches a year in the next 5 years probably. And this year, 2016, we will launch over 20 times. So among these launches, half of them are for the LEO. And then we can offer this kind of opportunities to these customers which need the launch opportunity for small and nano satellites. And also, as I mentioned earlier, we have developed the Long March 11 and Long March 6. We can conduct launches for multiple satellites at one time. And then this can also keep the cost down for this kind of opportunity. So I think that is basically what I want to say currently.
Well, thank you very much. It's exciting to see so much activity in the China launcher community and the evolution of those launchers, and I'm very interested to see the small and micro launcher. I think that's always an exciting industry in these days. I'm going to actually skip over Martin for a second and come back to you, because I want to hear the launcher companies. I don't want to get the guy who actually has to negotiate and buy with them. So Ben, you were with X-Corps Space Expeditions. X-Corps has been known for their reusable rocket technology. Can you talk to us about the potential and future reliability and affordability of access to space, and will it ever match the achievements of the airline industry?
Thank you, Andrew. Well, you have a great background in that area as well, so you could answer these questions, but I will do it for you. I have to make a confession. I never really was much into space. My background is aviation. I like flying, fighter pilot. Why was I not much in space? Because space for me was, if I had chosen to be an astronaut and if they had selected me, I would have had maybe one chance in my whole lifetime to go into space. And then I prefer an aircraft fighter, F-16, that's my life, and I flew 3-4 times a day until I touched on what is today called new or commercial space, and where the key word is accessibility, reusability, simplicity. So with our company, X-Corps, and there are more around, it's a revolution in space, you solve the problem of access to space. Up till today, there is no easy access to space. Why is there no easy access to space? Because space, it's a difficult area. I mean, you could even say it's a hostile area, or a very hostile area. No way that you can survive in space like you can survive in the atmosphere. You can jump out of your aircraft at 50,000 feet and survive. That's not the case in space. So to make it reliable, to make it safe, to make it affordable, you need a complete new system. A system that really assures that you can go into space whenever you want. And with all respect for France and China, if I want to launch my satellite, I have to go to Ariane in France or ESA or to China. What our company offers is that you can fly out of your own country. Why? Because our system is so simple you won't believe it. It takes off as a space plane from a regular runway here at Abu Dhabi, if need be, and it comes back to the same runway under its own power. Now, everything that's simple, we know that in practice, technology tends to be complicated, but our formula is to keep it as simple as possible. And therefore, we think that we offer a very low threshold for customers to have their own access to space at their own time, at their own will. And we pretend, we have to make it true next year with the first flights, that we can offer 2-3 times per day similar flights into space. Albeit to 100 kilometers, but that maybe is something for a follow-on question.
Understand. So Martin, the guy who builds the satellites, and actually we're in the presence of a great man. I think you really created the small satellite market. I'm pretty sure I could say that safely. You know, except for some of the very first satellites, which were by nature small, you perhaps rediscovered the beauty of smallness after everyone had gone big. And now the whole world's following Surrey satellite. So my compliments to you for that vision. Talk to us about, you know, how the new launcher designs are driving the satellite designs, and how potential future technologies, such as perhaps the Sabre engine, if they mature and enter the market, how that might change even more the satellite designs. And if you could, meld into your response the opportunities that reusable first stages might do to that equation.
Well, thank you for that very kind, but I'm sure unworthy introduction. It's certainly true that small satellites probably took a couple of decades to surface from their initial concepts, but in the last, perhaps 10 years or so, they've become quite fashionable. And one of the reasons for this has been the, of course, dramatic advance, particularly in microelectronics, driven primarily by the consumer market and the adoption of what is sometimes called commercial off-the-shelf technologies into the space environment in a knowledgeable way, which can then reduce the size, the time scales, and the costs whilst increasing the capability. But the constraining factor has been and continues to be the cost of access to orbit. So I'm indeed a friend of anybody, or I would like to be a friend of anybody who has launch capability and can reduce the cost, because there's no doubt that at the moment, even in the small microsatellite, mini-satellite community, the methods that we employ to design the spacecraft are still, to some extent, modulated by the cost of launch. There is no point in producing a spacecraft, let's say for $100,000, if it costs you $10 or $20 million to launch. It doesn't drive the mechanism. However, if we look now at what has been emerging in recent years of the proposals for a number of what are sometimes called mega constellations, but at least constellations of hundreds, possibly even 1,000 satellites of a relatively small nature, that may start to drive the process in a different direction, because we are now looking at manufacturing, which is perhaps not mass production, but it's certainly in large scale. Mm-hmm. And that means that the cost of manufacturing these spacecraft is going to drop dramatically. And we need to see, alongside that, a corresponding drop in launch. And then, of course, these two things will feed each other. Mm-hmm. If we really cannot just reduce the cost to launch by a factor of 2, but by a factor of 10, and some of the proposals that we hear about are hoping to achieve that, then, of course, there will be a different design approach to spacecraft, a different approach to service provision, and, of course, that will then hopefully spiral down so that we end up with many more spacecraft with a wider range of services in orbit. But one point I'd just like to add to that, and that is if you think about the installation of these new constellations, in the beginning, a bit like with Galileo and so on, there is going to be a sustained launch sequence of these hundreds or 1,000 spacecraft, probably done by relatively large launchers. Mm-hmm. But when we come to replenishment, mm-hmm. which may not necessarily be in all planes at once, it may be individual spacecraft, right. Then what we will need is very cost-effective, smaller launchers, because it won't be effective to replenish necessarily using large launchers unless there are some dramatic changes. So I think that the combination of some new technologies for launchers coming in using perhaps air breathing and similar type engines, which may reduce the cost and increase the frequency of access to orbit, corresponding alongside the requirement for supporting these large constellations, taking a much more IT approach to the design of satellites than has hitherto been the case. I think we may see quite a dramatic change over the next 5 to 10 years.
We might see Moore's Law actually take hold in the satellite world. Yeah?
Well, I think if you look at the satellite world over the last couple of decades, it's in the small satellite area, it's very definitely followed Moore's Law. Hopefully, we haven't seen the same apply to launchers.
Yes, it's so true.
But hopefully it may come.
What do you think that price point is, though? I mean, if you had a 100-pound, 100-kilo satellite, and the price per kilo might not be that good, but the price of the launcher is low enough that it becomes sure we can launch one every couple weeks or a month. Is it?
Well, it's not quite so simple because there are different dimensions that you need to take into account. Sometimes mass dominates when you have a big satellite, but as you have a smaller satellite, it may be volume that dominates, and therefore it's a question of how many of these satellites can you physically fit inside a fairing. And it was quite interesting a year or so ago with a former PhD student of mine who's in the US Air Force Academy. We decided to do a little study on what is the optimum size for a small satellite. Because we hear of CubeSats and mini and micro satellites. And the real quantity is actually not the size or the mass or the cost, it's the utility. So it was a question of looking at what sort of volume and what sort of mass corresponds to a sweet spot in utility.
Right.
And the answer, for those of you that are Hitchhiker Guide fans, was actually very close to 42. But in terms of kilos and cubic meters, cubic liters. And but the important message here is that it's actually not a very simple equation.
Right.
But there is a sweet spot where the laws of physics allow you to do something useful in a small volume with adequate power, and then that probably will start to drive the launchers, because I think you will find that the sweet spot is probably about the size of this table or the size of this chair.
Right, yeah. And so would $5 million be, that's a simple price, I'd pay that any day of the week, or is it more, or is it higher, 15 million?
I mean, for a single satellite, if you're talking about, no, I think we're being able to be producing spacecraft in the hundreds of thousands of dollars. Therefore, we're looking for hundreds of thousands of dollars
on the launcher
for the launch.
Gotcha.
The low
And
hundreds
that-
of thousands of
and that
dollars
drives you into
for
the
launch,
Sabre.
and then that will drive the synergy.
Yeah, and that sort of drives the Sabre solution. Okay, well, Jean-Marc, I've been waiting to ask you the question. Okay, so what's your real view of reusable launchers? You know, your competitor has been saturating the technical airwaves with reusable, and Ariane 6 is going a different way. So what's your opinion, and do you think it's really going to reduce launch costs?
I think our final target is not reusability, it is to decrease the cost, at least for automatic launchers, not manned launchers, of course. And we don't know whether reusability can lead to cost decrease. Maybe, maybe not. We think about an economical equation, you know, to state whether reusability is a cost-effective solution or not. Sure. On one side of the equation, you have the cost saving by recovering the first stage. We are only speaking about partial reusability, not complete one, in the case of SpaceX. Well, we have to give figures. The cost of a first stage, if you have a B stage launcher, is about 30% of the total value of the launch. 30%. So you only recover 30% of the total value of the launch. So this is on one side of the equation. On the other side, you have all what goes in direction of increasing the cost in the case of reusable launcher. First, you have a loss of performance. You are forced to use propellant to recover your vehicle. It has a cost in terms of performance, so it has a value in terms of satellite not launched with that propellant. This value is between 20% to 50% loss of performance by recovering your first stage, whether you recover it on the launch site or on a barge under the trajectory. Second, you have to invest in additional infrastructures. it has also a cost. It has to be reimbursed in the exploitation phase. You have a loss of reliability because you refly a stage which has seen an environment that you do not completely master. You have a loss of availability. You know, availability is very important for the customer, the capacity to be launched on a certain day and time. If you have to take into account constraints because of recovery operations like meteo and so on, your availability of the launcher is not as good. So you have to transform it into dollar too. And additionally, you have some additional hardware that you have to put on the launcher to recover it. So that equation, frankly speaking, I do not know whether it is positive or negative today on reusability. What we see is that, yes, it is worth to work on that. We certainly have to think about future launchers with reusability, partial reusability. It has to be worked out first on the engine level. You know, SpaceX has been successful by reusing the Merlin engine that was developed by NASA in the 90s. It's a good engine, and then they define the launcher around the engine. So let's work on future engines, reusable, floatable, and so on. And maybe that will lead to a new division by 2 of the cost in the future. But that's maybe. With Ariane 6, we are sure to be able to decrease the cost by 2 now.
We have the solution, Jean-Marc.
And what is that, Ben?
Is it my turn?
What is that, Ben? Tell me.
Well, I gladly, I'm a great admirer of CNES and of course what's been done with the Ariane and for that matter China. But the secret of our X-Core success, what it's going to be, is the engine. It's not so much the spacecraft, because you can build anything around it or a vertical rocket, but our engine technology, that's the genius, is 5,000 times reusable. That's what we say. You know, we will see in practice what it is. But basically you fill it up with kerosene, with oxygen, some helium, and you fly again. We pretend our vision and mission is that we will fly 4, maybe 5 times per day. That's a real revolution. Will that happen? Well, we have tested this engine 4,000 times on the ground at Mojave. Proof is there. We have to prove it in the air, of course. And the key of reusability, indeed, I think, is always the propulsion. The big gains in aerospace have always been made through propulsion advances. And is there much secret to it? No, it's the very basis again is simplicity, simplicity, simplicity. And it's a genial idea, and yeah, we gladly share that success with you. And we decided to build a space plane around it, but again, that's not unique. You can build anything around this kind of engine. So yes, I do fully agree. It's the engine, and that will be the core of our success.
So Martin, I'll ask one more question, and then we'll open it up to the audience. You mentioned earlier about the great advances in satellite technology through the consumer electronics market, the use of iPhones now to drive CubeSats, for example. But clearly, there's a lot of activity here in the region, and in particular with the UAE Space Agency being started up recently. What do you see the contribution of the region in terms of some of the new innovative satellites that might be produced here? And what's needed locally in order to make that happen, do you think?
That's an interesting set of questions. Let me try and answer them first of all. And these are my opinions because we have our colleagues who can speak to the future of the UAE much more in a much more informed manner. But I think they're really twofold. In the first case, in every new player that enters into space, into the space activities, brings with them a new thinking process. And so because inevitably they are starting from essentially a blank sheet of paper and deciding what it is that they would like to pursue for their national interests, they can afford to look at the whole area with a completely fresh set of eyes. not only with a fresh set of eyes, but with a different set of skills. And so I think what we will see from the UAE as well as other countries that are beginning to take their greater interest in space is our solutions and ideas, businesses, methods of exploration that will be different from those that have been in space a long time. And this is a natural human evolution, fresh ideas, fresh spaces. And what is going to be required for that is essentially human capital. And so, as has been mentioned, I think, numerous times during the summit, one of the most important elements for the UAE in particular is to develop that human capital. First of all, so that they can satisfy their own ambitions, but also to stimulate the younger generation to be able to address these challenges, which will also have spin-outs into other areas. It will not just be the stimulus of an interest in space will stick just with space. Sure. They will move into other sectors, even the finance sector. We might benefit from many who have a mathematical and other scientific approaches. So by stimulating young people by having a space activity, we'll create career opportunities for them to stay in the country and develop it, to meet national goals, but it will also spin out into many other sectors of society with a beneficial result, I believe.
Yeah, well, certainly we saw that from the original space age in the United States when all of these young people were stimulated by Apollo, who ended up doing things like Facebook and, well, he was a little young, but Apple and many of the others. But exciting times ahead. So does the audience have any questions for the panelists? Yes, sir. Olivier. Is there a microphone? Oh, there we go. The nice gentleman's here.
So I'm Olivier from the Space Agency. In fact, we had two very interesting keynotes yesterday at the introduction of this conference. And I would like to send back a little what they say. The first question is maybe more towards Sir Martin, but it could concern the rest of the panel, is that it has been said that in the space sector nothing is set, and we cannot consider that what we trust will be the future. And saying that the constellation of CubeSat or microsatellite is what a lot of people are seeing as the future. But what is your analysis of having so many satellites around the Earth at the same time in terms of debris, collision, interferences? And could that kill, in fact, this process? And the second question is more for X-Core. And we had the test pilot of Virgin Galactic that made a lot of comments about having a single rocket engine about to take off and land from the ground, and saying that one of the main issues with this kind of engine is the lack of flexibility, if I can say, to pilot the spacecraft. So if you can comment on this statement.
So who wants to take the first one? Martin, you want to take the first?
I'll take the first one, and I'll give you a chance to think about the second. First of all, a personal view, and it goes back to the comment that I made a bit earlier, is that I think nanosatellites, and one particular application of those is the CubeSat, sort of description of them, extremely powerful for education, extremely useful for some research, and have some potential for some very specific services or applications. But I think we'll find that it is a slightly larger satellite, as I mentioned, in the tens of kilos to 100 kilos, where the application sweet spot might probably exists. I've forgotten your second question in the enthusiasm to answer the first one. What was the second one?
No, the second one was more about X-Core.
No, the debris issue, sorry.
The debris issue, yeah.
Yeah,
So the real, it was mentioned in a preceding session, the concern about debris, and if we have large numbers of satellites in orbit, this debris question may run out of control. I think the key there is not so much just the numbers of individual satellites, because space is big. and the numbers we're talking about are still relatively small compared to the scale of space debris, which is in the 500,000 to 1 million pieces of space debris. We're talking about adding, at the best, a few thousand pieces. The real danger is when any of these satellites fragments. So if we have a large constellation of satellites and they have onboard energetic materials, propulsion and so on, then it is the danger of fragmentation, which by itself can then create very large clouds of thousands of pieces of debris, which has to be controlled. So I don't think that the sheer numbers of satellites by themselves is going to increase that risk dramatically. But the design process is when we go to increasing the availability of space to new players, being aware of the dangers of satellite fragmentation. That is where we need to pay the greatest attention, because debris is a real problem. One of our satellites in the 1990s was hit by a piece of space debris and lived to tell the tale, I hasten to say, but it was a very, it was a wake-up call for us. Debris is a real issue. We must minimize it, but we must pay particular attention to, say, fragmentation of spacecraft.
Ben?
Yes, you mentioned Virgin Galactic. Let me first state we are neighbors at Mojave, and I'm a great admirer of what they do. I'm sad about their accident. We know what it caused, and it was a human factor, so by itself not a design factor. And we know that in aviation and in space, things do happen. But if you want to build a commercial space or a line, we call it space line, on this new aircraft, new spacecraft, then of course you can't have those accidents. You should reach the levels of you coming in to Abu Dhabi here, which is a much safer level of, let's say, avoiding accidents than what happens up till today in space. So reliability, safety is a major player, of course. If otherwise our company would fail if we would not succeed. Same goes for all the other new space companies. But there is a similarity to what Virgin Galactic is doing and what we are doing. We are both going up to 100 kilometers. So it's the same experience for the people on board, or payloads or microgravity science, whatever you want to explore. But the systems are completely different. The propulsion is different. You could say, I'm not all that knowledgeable about Virgin Galactic, but it's no secret that their propulsion system is basically a classical rocket system. Ours is a system that you can compare with your car engine. You start, switch it off, start it, switch off, and you can do it hundreds of times. And that makes it a completely different proposition. And we are rather unique in that sense. And it took some years to develop that, but that's our intellectual property. Does this satisfy your question?
Good. So, Martin, a quick follow-up. I'm going to ask Mr. Wu one final question.
Yeah, I mean, just a point that I'd add to that, and that is I think we're also going to need to have a bit of a change in approach to risk.
Yes.
And, well, it's not so much risk, but the perception of risk. Because it depends how you measure risk to human life. Is it in mortality per passenger mile, in which case cars are pretty lethal? Is it in terms of putting it into perspective in the early days of aviation?
Yes.
At the moment, we have a very, very high intolerance to space flight risk. And I think we probably need to start to educate ourselves to become a little bit more pragmatic and put it into a better scope.
Very, very good suggestion. Mr. Wu, there's been discussion today about the nano satellite and microsatellite launchers. And you mentioned earlier in your discussion about Long March 11, I think is your product. Rocket Lab from New Zealand is advertising, I think, about 100 to 200 kilograms for $5 million. Firefly Systems from Austin, Texas, I think is in a similar range. Do you think that Long March 11 is competitive in that market, and what do you think is going to be its big driving success?
I think we can easily beat that kind of launcher because our Long March 11 is designed for this kind of market. We see that the growing demand for the launch of the micro and nano satellite. So we know the people are talking about As Martin said, that they developed satellites. Sometimes it's small, but it's quite large in volume. So this is the kind of challenge we have to consider. So for our Long March 11, one of the advantage is also mobility. It can be launched anywhere. Just like XCOR, it can be launched from any country. But of course, we know this kind of technology are subject to some international regulation. You cannot find a place just launch. You need to get agreement with the local government or something. But for us, this kind of Long March 11, we use the mature technology. There's not too much development cost. And also, it has a different fairing for different missions. For this launcher, it is a 4-stage launcher. It has the capability of about 400 kilograms to an orbit of 700 kilometers. So the target market price we are talking about is about 10 million US dollars. So I think this kind of launcher actually can support many of the programs here. We understand, compared to some of the piggyback programs, maybe there's still room for us to improve our price. But some people, regarding the piggyback opportunity, one of the headache for the satellite developer is the schedule. You may wait up to 2 years, even longer time. You don't know when your satellite can be launched. Your satellite is waiting for the opportunity.
Yes.
But for us, with this kind of launcher, we can provide a dedicated launch even, if the operator, they want to have an urgent need. So I think also referring to the question from the audience talking about the constellation. So I think this kind of launcher is ideal for the replacement launch. You can deploy the constellation with larger launcher, as Martin said, but sometimes you need a replacement in case of any anomaly in orbit.
Yes.
So I think we can do this job.
Well, it sounds like you're going to have lots of great business with the Long March 11.
Now, if the U.S. government allows us to do that.
Well, I'm sure you will. I'm sure you will. Well, it's wonderful. If there's one last question from the audience, I've been signaling. Oh, yes, sir. Oh, wait, hold on. We've got a microphone. Please give us your name and what organization you're from, and then your question.
Dr. Mu'taman Mirani from Isra, Sudan. I ask about possibilities for using fighter aircraft in launching small satellites. Is it possible?
The question for me?
Yes.
Yes, the United States Air Force has had, and I think they still have, a program. It was based on the F-15 Eagle fighter airplane, and that was modified and equipped for an air launch. Now, I don't know exactly where it stands today. Maybe you know it, Martin. But the fact of air launch is getting very popular as well. So air-launched rockets, not necessarily by fighters. That's mainly for military programs. But air-launched as being undertaken by Paul Allen with the Strato launcher, and Virgin Galactic also has a program for air launch, and there are more around.
Yeah, and there's another one in Georgia called Go Launcher. Yeah, there's another one called Go Launcher.
Yeah. You think it will reduce the cost very rapidly?
Yeah, well, yes. If you take the Strato launcher, I don't know whether you have seen it. It's 2 747 airplanes melted together, 6 engines, 2 huge fuselages, and they can carry an air-launched rocket. And the idea is that the air-launched rocket comes back also and be reused. Yeah.
Okay. Also, I mean the power of the fighter aircraft jet as a booster.
Yeah, actually.
Yeah, well, that's the principle of our Lynx Mark III. We will launch small satellites up till 15 kilograms, exactly what you are producing. And we do that once we are up there at Mach 2.5, Mach 3.0, 100,000 feet or so, and then we air launch the satellite. But that's still 3-4 years ahead.
Yeah. So. Well, I would like, one more, okay, one more final question. Our friend from Romania, the good doctor. And then we'll wrap it up, because I know we're over time.
That means I want to outline a simple question for all the audience. Everybody knows this. The matter is how we can reduce the risk for the whole operations regarding the space conquest. Actually, everybody is talking, I don't know how much we are doing practically, and we are developing a real solution. I'm talking about two things. I'm talking about the radiation hardening, the test of the components. You should be crazy to send Jupiter mission, a mission to Jupiter of $2 billion, and when the space mission will reach the atmosphere of Jupiter, all the sensors will die, and they will become a simple piece of metal which will land on Jupiter, and that's all, finished. All the money, the mission, everything, will be done for nothing.
Yeah.
Was done for nothing. The second is the space debris. We are talking about space debris. Actually, the level of incidents, there is one per year. This is the statistics. But we are talking about something like 2,600 satellites, dead bodies, which are running into the space, plus tens of thousands of pieces between 1 and 5 centimeters, between 5 and 10 centimeters. We should do something. Everybody's talking about, okay, we will use fiber laser intolerant satellite, which will push by laser pulse the pieces, this dead body into the atmosphere and will burn. Okay, actually, we have the Americans. They finalized the Lockheed Martin, the 60 kilowatts continuous wave laser, which we can destroy it from the ground. Something should be done very quickly, because if we want to send passengers, you should think how much will cost the insurance, because, and which will be, okay, in case of accident, how much the insurance will pay, because maybe I will buy a ticket for my mother-in-law in this case. Thank you.
Well, thank you very much. So just a quick wrap up. We heard from Jean-Marc, and we're looking forward to Ariane 6, and best of luck with that project, and I'm sure you'll drive those costs down, and we look forward to a great launcher. Mr. Fu, we thank you very much for summarizing the new launcher programs, and good luck with your new launch site. Looking forward to that. And Martin, of course, I'm not going to take the accolades away. I still believe what I believe. You've really pushed small satellites and created a great industry for a lot of people to follow you. And Ben, of course, you know where my heart lies, and best of luck with getting that vehicle off the ground, and we look for great success.
Thank you.
Thank you very much to the organizers. Thank you very much for sitting in on our panel, Dr. Al Habibi. We appreciate your presence and your patronage here. And thank you for the audience for very, very wonderful questions.
Thank you.
Bye-bye.